Okay, great. So now let us look at this. If x follows a geometric distribution, figure out what is the expected value or the expectation, and then figure out what is the of 1 over 2x here. So, okay, let's see. So if x follows the geometric, then we know that the range is going to be all the positive integers, right? It's something we know. And also the PMF is going to be, well, let's see if P is the successful probability, let's Q to be 1 minus P. Okay. So this is going to be Q to the power K minus 1 times P. Okay. And of course, K is from 1, 2, 3, 4, 5. Now, noticing that P and Q are both between 0 and 1, so the P of x can be written as the summation K from 1 to infinity K, right, times Q to the power Q minus 1 times P. Okay. So P is a constant. So we can factor this out. There is nothing related with K here. K times Q minus 1. Okay. So this is what we get so far. So now things become slightly tricky. Why? Because apparently we're looking for the sum of this series, right? And it turns out that to figure out this sum, we need some result from the series pieces. So remember, if you have a geometric series, for example, so if you have K from 0 to infinity, x to the power of K here, and if, provided that the absolute value of this common ratio, x, is less than 1, so we know that the sum of this geometric series is going to be the first term, which is when K equals 0 to the 1 over 1 minus x. Okay. That's something we can handle. Alright, so now if we know this result, and noticing that if we can take the derivative of this, that's going to be K times x to the power K minus 1, right? And then on this side, the derivative of 1 over 1 minus x is going to become into 1 over 1 minus x squared. Okay, so you can easily to verify. The index here, you can write it K from 0 or K from 1. Why? Because when K from 0, this part is still 0, so nothing hurt. So you can put this index as K from 1 to infinity in this pieces. So now, if you do a comparison with this part and this pieces, don't you agree that since Q is between 0 and 1, it's going to act the same rule as x here, right? So this is a p times 1 over 1 minus q, right, square. And we know that 1 minus q equals what? Do you see? Is equals p, right? So the p over p squared turns out that the mean is equal to 1 over p. So now this makes sense, right? Why? Because if you think about it, the random experiment following this geometric distribution, you can think about one example is we toss a coin until we observe the first head, right? Of course, the probability of a head is defined equals p. We found that on average, you need to toss 1 over p times in this experiment. In other words, if p is very small, okay, so in other words, the the probability you're getting ahead for each trial is very, very tiny. Do you agree that 1 over p is extremely large? So in other words, you can expect that you need to toss the coin a very large number before you observe a head. Okay? So, on the contrary, if p is fairly large, you just need to toss the coin, a few times, and then you expect you're gonna observe your first head. Okay, so that is how to redrive that part. So moving back to the second pieces, we're looking for the expected value of 1 over 2 to the power of x. So in this part, noticing that we're gonna using the law of the unconscious statistician, short for the lotus, right? So in other words, this expectation equals to k from 1 to infinity. It's 1 over 2 to the power of k times q to the power of k minus 1 times p. Okay. And you can do this. You can reorganize this as p over 2 times q to the power of k minus 1 over 2 to the power of k minus 1, right? So realizing that, we can factor p over 2 outside, k from 1 to infinity, so it's q over 2 to the power of k minus 1. And of course, q minus 2, do you realize that this number is also between 0 and 1? So this is a perfectly geometric series. So this is going to be 1 over 1 minus q over 2. Apparently, you can get it's a p over 2 minus q, right? 2 minus q. So yeah. If you want to represent it in terms of the p only, what I'm doing. So it's this part, p over 2. This is the geometric series. With the first term is 1, common ratio is q over 2, so you can do that part. You multiply it, so it's p times 1 is p, 2 times 1 is 2, minus 2 times q over 2 is q. So remember we said Q equals 1 minus P, right? So you can drive this as a P over, let's say it's only 1 plus P. So that is the expectation. Okay, so hope you enjoy this.